G'day everyone. Welcome to the Future Ready Apps Summit. My name's Brian McCurr and I'm an open source database specialist on Azure. Today I'm going to walk you through some of the benefits and advantages of using open source databases as a service on Azure. Okay, now let me start by saying that what we see in the marketplace is that all around the globe, enterprises are embracing open source databases. Two of the most popular databases are MySQL and Postgres. These databases frequently win awards for Database of the Year and are sought after by developers and enterprises alike. From an industry analyst perspective, Gartner believes that by 2022, more than 70% of in-house developed applications will be developed on an open source database. And further to that, by 2023, they also predict that about 75% of all databases will run on the cloud. So you're in good hands using open source databases on Azure. Talking about our offerings, I'll give you a brief overview. So first of all, we offer a fully managed database as a service. And I'll dive into the details of exactly what that means in the next slide. We pride ourselves on the fact that we build our databases on the community versions of those databases, MySQL, MariaDB, and Postgres. We handle all support for upstream projects, so there's no need for a customer to liaise with the community to have bugs fixed or issues resolved. These databases are considered first-class citizens on Azure, and they integrate with the Azure data ecosystem in line with our commercial offerings. And where possible, we try to make them developer-friendly. So the first question might be, what is database as a service? So if you look at this diagram here, on the left, we have a typical on-premises scenario. In the middle, we have an IaaS scenario. And on the right, we have a database as a service or a platform as a service scenario. In the on-premises scenario, the customer is responsible from data center all the way to application security. When you move to IaaS, there is still a large area of responsibility. However, your cloud service provider will manage data center, hardware, and probably virtualization. However, the customer still has to manage operating systems, database provisioning, scaling, high availability and DR, backups, of course, data and applications, perhaps even performance management and threat detection and risk management. Moving to DBaaS, things get a lot better from a developer perspective. And from a platform perspective, we do the heavy lifting on the operational administrative tasks. So not only do we look after the data center, the hardware, the hypervisor, we also maintain and secure and patch the operating system, the database, and we make it trivial to enable high availability, DR, backups, and so forth. This allows you, the developer, to focus on applications and data. On top of that, we also have an additional unique service where we provide performance management capabilities as part of the platform and an optional threat detection and risk management capability. So what are some of the features that we provide as part of the service? I touched on these in the previous slide, but things like scalability, where you no longer have to pre-purchase hardware and manage those assets. We provide monitoring and integrate with standard monitoring systems. We have backup and restore capability. High availability and DR are trivial. We do minor version patching as part of the monthly maintenance. We have migration tools that allow you to get your data both in and out of Azure. We integrate with the rest of the Azure data ecosystem. And we provide developer tools such as provisioning and automation capabilities, Terraform, ARM templates, etc. Some of the key features of our database as a service, and this is across MySQL, Postgres, and MariaDB, are up to 104 vCores for a single instance of a database, up to 80,000 IOPS, which is phenomenal performance. Database size is up to 100 terabytes. We offer an RPO of 0 when you configure with the zone redundant high availability option. That means 0 data loss across availability zones in Azure. The RTO for these services is typically less than 120 seconds, and it's platform managed. And with the right configuration, there is no need to make any application changes for failover to just work. We also have the read replicas, which allows you to scale out your read workloads, and we'll demonstrate that in a moment. And we also have a scale out database option with Postgres. This allows you to scale beyond a single node database to a multi-noded database that can handle a phenomenal amount of scale that can be required by some of today's applications. So if you choose to deploy your databases on Azure, what do you get? I talked about the integration. Along with that, we talk about the full management of the service, the intelligent performance capability, the scalability, high availability, and the control that allows you to focus on applications and data and not operational tasks. We're fully committed to open source, and we use the community version of these databases on our platform. They have proven resiliency and stability, and they have a rich feature set that we take advantage of frequently. What sort of applications do we see developed on Postgres around the globe? There are many. However, some of the common patterns are some of the ones you see here. So we see modern transactional applications built with containers. We see real-time operational analytics, leveraging our hyperscale Citus offering. We see geospatial applications using the open source PostGIS extension. We see time series and relational data systems. And of course, we see more and more customers migrating Oracle workloads from Oracle to Postgres. From a MySQL and MariaDB perspective, we see a number of different application types. For example, I'm sure you're all familiar with LAMP. We see a lot of web apps using LAMP, for example, WordPress, Drupal, Moodle, etc. We see e-commerce solutions using homegrown applications and applications such as Magento. The LMS I touched on earlier, Moodle, we see that deployed around the globe using MySQL on Azure as the underpinning database. We also see microservice architected applications, and in particular, there's some interesting payments and financial services applications making use of the MySQL database. And we see a lot of organizations taking advantage of the database as a service to reduce TCO, reduce operational overhead, and focus more on applications and data. So now what I'd like to do is show you a demo of a read replica using the Postgres database on Azure. In this demonstration, I'm going to show you how easy it is to create a read replica of an existing Azure Postgres SQL database. When would you use a read replica? One of the main use cases is when you want to offload an analytical workload, for example, to a read replica to relieve pressure on the primary or the master database. So let's go ahead and walk you through how easy that is. We've got an existing Postgres database here in Azure from the portal, test PG-SSS. So what I'm going to do is I'm going to clone that server to one with a new name in the same region. So I jump over here where I've got the CLI installed, and I have a CLI command which is going to create a replica. The name is going to be testpgrep, and the source server is testpgss. So I'll kick off that replica creation. That'll take a few minutes. In the meantime, we can go and walk through some other portal options. With your Postgres database, you can obviously create a replica via the portal. It's simply a case of coming in, choosing the replication menu here, clicking Add Replica. You choose a server name. So if we choose that one, you choose a region. Interesting to note that you can create your replica in another region. That can be used for disaster recovery as an option, or it can be used as the standard read replica. You can create up to 5 read replicas across 5 separate regions. Note, however, the replication is asynchronous. So for heavy write workloads on the master, there may be some replication delay. I'm actually not going to perform that through the portal because it's happening in the CLI for the same source server right now. In a moment, the new replica will appear here once it gets to a certain stage of the provisioning, and we'll be able to go and check its details. Essentially what you get is a separate instance of the Postgres database. It has all of the features and functions the same as the source database or the master. However, it's in read-only mode, so we'll demonstrate that as well. But it is a standalone server, so you can connect to that with pgadmin. You'll need to update connection security details to allow connections from external networks, for example. So it lives and breathes exactly the same as a primary database, with that one exception that you can't change any of the data through external means. So while that's running, we'll connect to the source database and create some data for our demonstration. This is the source database, test PGSS, and in the Postgres database, I'm going to create a table called my table. We've created the table. I'm going to insert some data. Now this is 1,000,000 rows. Okay, so we've successfully inserted hopefully 1,000,000 rows. If we select the count just to make sure, there's our 1,000,000 records. And if we look at the max ID, that's 1,000,000 as well. So right now, while the replication is happening, the write-ahead logs of Postgres are being asynchronously replicated to the replica. When that replica has completed, we'll be able to connect and query that data, and we can have a look and see just how quick that replication is. Here we go. So in the portal now, we can see in the replication menu, a replica has appeared with the name test pgrep that we specified on the CLI. Notice that the pricing tier will be identical. They're both in the same region as we specified, but currently the replica is unavailable. That's to be expected as the replication process hasn't completed. As I mentioned, when the replica is available, we will have to configure it to allow access from my current IP address. Shouldn't be too far away now. Okay, so connection security is where we will go for. This is the primary. We'll go in here and we'll add an entry to the allow list to allow my IP address to connect. Okay, it's still unavailable. Still running. So maybe what we'll do is maybe we'll insert another 1,000,000 records. Okay. Okay, we've got 2,000,000 records in there. Shouldn't be too long until the replica is ready. Now, given I know what the database name I chose was, I can create a connection in pgadmin. Okay, so our replica is complete. It's finished. And server name here. So I've already set this one up. The username will be dbadmin, but the server name's different because it's a different server. So now I should be able to connect to the replica. No, I shouldn't. I'll have to go in. I'll have to go into the connection security. For the replica. It's available now. Go into the replica, connection security, add my current IP address, save, back to pgadmin. Okay, so we've connected to the replica. Just make sure you connect to the right one if you're trying this at home. So I'll bring up the query tool. And I'll copy both of these commands over here. So we're on the replica. What's the count in the table? 2 million. So therefore I think max ID is going to be 2 million. What happens if I try to, something simple, drop table, my table? Well, you cannot, because it's a read-only transaction. It essentially means the database is in read-only mode. If we go back over to the master and insert another million rows, while that's happening, I'll select a count. There you go, 3 million rows, so it's caught up already. Very useful if you want to offload a read workload to another replica without affecting the resources on your primary. I might have mentioned you can create up to 5 read replicas. Okay, well that concludes today's session and demo. Hopefully that was very informative for you. Now the session continues with my colleague Karishma, who's going to talk to you about CosmosDB on Azure. Have a great day.
Thank you so much, Brian. Hi, everyone. Welcome. I'm Karishma, Azure Technical Specialist, Global Black Belt team, and I am focusing majorly on building innovative applications with CosmosDB, NoSQL and Azure from the data and AI domain in Microsoft. So today we'll be covering how CosmosDB can help with applications which are growing with high volume and has a requirement of low latency. I'll be touch basing on one of the feature of CosmosDB. Let me take you to the presentation or to the session. Yeah. So I'll give you a quick intro on what CosmosDB is in the first place. So NoSQL is categorized into 4 different parts. One is key value databases, where you have all the key value pairs, scalar. Then you have column family database. You have document databases, where you have JSON documents and you have key value pairs with complex nesting. And then we have graph databases. So Cosmos DB covers, it's like an umbrella which covers all these kind of categories of NoSQL demands. And with its APIs, where it has its own native API, which is known as Core SQL. It also has MongoDB API, Cassandra API, Kremlin API, and Table API. So that's why Cosmos is known as multi-model database, where you can start your using NoSQL for your huge volumes. Plus, you can also migrate your on-prem or IS workloads to NoSQL. Apart from Cosmos being multi-model, it has 4 more powerful capabilities, which is nothing but having higher throughput. It gives you an SLA of milliseconds when you want a highly responsive database with an RPO of 0. So it's highly available with 5 nines. You can go limitless with Cosmos DB. So be it GBs of data, petabytes of data, or more than that. uh, it doesn't give you any issues when it comes to performance, when it comes to scaling that much of data. And it becomes very responsive as well because of its auto sharding and and auto indexing and multiple features. And last but not the least, it is globally distributed, so it is there wherever the user is. These are the concepts which are there in Cosmos DB, which makes it highly capable. And today I'll be focusing on caching in Cosmos as well as how analytics works in Cosmos. So before going to how we give caching in Cosmos, why caching is required, what are the main reasons why developers go with caching when they have to interact with databases sometimes. There are two major reasons. One is speed, where you don't want to compromise on your speed, your latency. Definitely, Cosmos is built for that, where you have milliseconds of speed. So, why do we require caching in that? Maybe you want in single digit. What is more important? The other factor is, which is very much important, is cost. You will be hitting Cosmos DB or your database for any operations that is like highly concurrent request, which can go to millions of requests in a second. What if you are requesting the same data? Or what if you're doing a same query on the same data? Do you really want to spend a lot of money in terms of, for your each and every request which gives you similar data? What if you want to do some optimizations on your cost? So this is where Cosmos DB came with the feature called integrated cache. It's an inbuilt feature in Cosmos. Thinking about inbuilt, what makes you feel that what is the added advantage which you get. So when you think about cache, what you think is maintaining a cache. What if there's a cache hit? What happens? What if there's a cache miss? What happens? And how do I do that? When the cache should get populated, how much should be the staleness and all that in the cache. So Cosmos integrated cache keeps you away from all these management, but using the underlying caching in Cosmos. And it is only dedicated to optimize Cosmos utilization. And that's when you use this integrated cache only with Cosmos and not with any other services. And it also supports multi-region support, which is Cosmos built for, where you want to do multi-region, right? And Cosmos caching allows that. With this cache, which is inbuilt with Cosmos, you don't have to, whatever applications or whatever SDKs you're using with Cosmos DB to directly connect with Cosmos DB, you don't have to do any code changes. It's inbuilt. So whatever is your code, the only thing which you have to do is the connection string where it should connect to if you want to use integrated cache. And that's all without any configurations. How to provision first of all, how this caching works. So you have to provision a compute for that caching, and that is nothing but in dedicated gateway. Why it is called as dedicated gateway, you can consider or think of is you have a compute which is taking care of routing your data as well as caching your data. So you have the flexibility over here, as mentioned, that there are three types of compute you can use based on what is your vCore requirement and what is your memory requirement. And you also get the flexibility of how many instances of that compute you want to use. Here we have used dedicated gateway, to utilize the cache. But you can also in future, we have plans of using the same dedicated gateway for other reasons, like feature optimizations or feature performance, query performance. The same gateway can be used for caching plus other requirements. So this is how the concept of dedicated cache is. Before, your application was talking to backend databases, but now Your application will now connect to your integrated cache, who will connect with your backend database, which is nothing but Cosmos, and it will connect to whatever partition it wants to connect to get the data. With integrated cache, there are two components. One is called item cache, and the other is called query cache. And how this item cache or query cache works is, or it gets populated, or where the data gets removed or purged from the caches based on time to live for that cache, as well as least recently used. That data gets removed from the cache based on whatever interval you set. With these two components, item cache is nothing but it's caching the data, the key value pairs, the items which are there, so which will be helpful for your point reads. And whatever you write, update, or delete on which specific item which is a part of the cache, it gets automatically reflected in the cache, whatever you do in the database. So, and also, if there is a cache miss, it the dedicated cache will go to the database, get the data, send it to the your application, and it will also put the data in the cache. So this is how it works when it comes to item cache. Now, what is query cache? Query cache is nothing but, consider that you have a query which you are querying to the database, and you are using that query one come again and again, like over and over, and it's more or less giving the same results because your data is not getting updated. Then it's better to use a query cache where the data is populated in the cache in the form of key value pair, where key is nothing but a query and the value is nothing but a query result. So whenever next time when you query the data, it goes to the cache and gives you the data instead of going to the database, which will help you optimize on the cost. So these are the common use cases, where you can think of using your integrated cache. One is cost saving. How do you do that cost saving? Be it item cache or query cache. If it is not going to your database and it is going to the cache, you're not going to cost for the RUs for any of the operations. Then when you want to have a low latency, so definitely there is some difference when it comes to latency. When you go to the database and get it, it's lowest, it gives you within 100 milliseconds, but with caching it gives you an improvised latency where it is lesser than what you get when you use Cosmos DB. It avoids hot partitioning. Now, what is hot partitioning? Consider a scenario where you are new with using partitioning, and your application is you don't know what is the response which is going to come to your application. Maybe you have a product and you have 10 different types of product. You don't know what is the usability of the product, and the initial stages you have selected your partition key as a product name, and then you realize with time that one of the product is being used or being queried a lot compared to any other product. So there will be, like, this is being utilized a lot, the RUs will be utilized for this product or with this partition a lot. It can end up in hot partitioning. So there are two ways to avoid it. One is you change your partition key. For that, you might have to migrate your data. The other is, for temporary reason, you use integrated cache, where you cache your data in your cache, and your data will be queried in that with that cache instead of hitting the database to that partitioning, and that's how you can avoid hot partitioning. And you can also avoid using high RUs. So consider a scenario where you're using a query, where you're querying a database and it costs you around 100 RUs. The results that you have stored in your query cache, the second time you hit and you ask for the same query, instead of going there and costing you 100 RUs again, you go to the cache, it will give you the results with zero RUs. And that's how you avoid the number of RUs, and that will reduce. Maybe consider that, a lot of your RUs. Consider this 100 RUs is for one query, and that query you're using it again and again every second, maybe 10,000 times. So it is like 1 lakh RUs you're using. It can reduce to 100 RUs only if you use integrated cache. Workloads that are not good fit for it is, when you have a read intensive workload, it is the best fit. But when you have write intensive workload, you don't need an integrated cache because you have to eventually write it to your database. So doesn't matter if you have a cache to write or not, it is going to write. In fact, you'll be paying more for having an gateway, paying for the gateway instead of just paying for the database. So, and also it is not useful when your requirement for the query is you query the data and every time the query is different, or you expect a different data, or you don't have the you don't want to compromise on even a minute of latency, a staleness in your data, in the cache. Like, maybe in the cache you have a staleness of 1 minute or 2 minute, and you don't want to work with that. So that's when it's not a good fit, I can say. So this is one of the example of item cache. Like, my application wants to write the data to the database, and I'm connected to my cache gateway instead of Cosmos DB. So what it will do, the cache gateway will paste it in its own local, and it will also paste in the Cosmos DB. The similar for the second item. And now when you want to read the document A, it will directly read from the cache, and when you want to read a document C, which is a miss in the cache, it will go to the database and it will give you the result. It will also put the data in your cache. Now, suppose if you want to do some kind of changes in the way that your document A has name Tim, but you're updating which is named Andy. So it will update in your Cosmos DB, plus it will also update in your cache. So it gets even though the staleness period you have set it to 5 minutes, before that if there is any update, it will automatically update your cache as well with that. Now there is one more example of query cache. So suppose you have a select query which is there in your Cosmos DB, which is not there in your cache. What it will do is it will go to the Cosmos DB, give the result, and store it in your cache. Similarly, if you have a data which is there, a query which is another query which is there in your Cosmos DB, it is not there in your cache. It will again go to the Cosmos DB, give you the result, and store the data where key is nothing but the result and the value is nothing but the result set. The next time when you're querying the data which is nothing but which is already there in your cache, it will take it from the cache and it will give the results instead of hitting the Cosmos DB. Now, what I'll do is I'll take you to a demo of how integrated cache works. So here is a demo for integrated cache, and this is the account which I've created with the name integrated cache Cosmos account. This is my database. I'm using SQL API, and this is my container. I've just given the name as container. I have items in this, and I've already populated data in this items. I will take you through how I have configured it. So here, in the left pane, you will get an option of get dedicated gateway. If it is not provisioned or disabled, you just have to enable it. And then you have to decide on what is the SKU which you want to use. Let me show you in one of the other Cosmos DB account where I have not enabled. So this is how you can provision. I don't have a dedicated cache. I want one. And this, I would like to tell you one thing about this dedicated cache is it is at account level, if you can see. So whatever databases, collections, or containers or items you create, you can cache it here. Like, it works like how your account is, and similar to how you have your account keys. Here you have created your SKUs and all that. You save. Once that cache is created, you go to the keys and you'll be able to see that it has this URI for account. This is your account URI, your account primary key. Similarly, you have your primary dedicated gateway connection string where you have your account key, account name, and you have your key. The account name is nothing but the similar name, just that suffix of the name, there's a tweak in that. You just have to add SQLX instead of documents.azure.com. So one thing about this integrated cache is it is at account level. So be it any container, you can use that. Now we'll take you to an application. I have created one, application which is and having which populates the data into the collection, and then it will showcase like how you can use integrated cache for your item cache as well as query cache. I've started my application, I'm running it. It gives me these options of measure cache performance. I want to go ahead and measure it. Let's see what happens. So it is showing you, first of all, write sample items. So even though what I've done is if I take you to my application.json, I have my regular account endpoint, regular account key. I also have my dedicated account endpoint, dedicated account key. Here I am connected to my dedicated account endpoint and I'm doing the writes. So it doesn't matter if it is you're using a dedicated cache or not, you're going to be charged for every write operation because it has to go to the Cosmos DB to write the data. Now what I'll show you is how point read works. So here what I've done is I have used, doing point reads without caching. So each time I run the operation, it is taking 1111 RUs for each operation which I do. Now consider I want to do my point read with caching. So this is what I'm doing with caching, and what you see is there are 0 RUs used. Why? Because the data is coming from cache and it is not going to the database. So even the 1 RU charge you are getting in your integrated cache, you're not getting the same over here. Okay. Without integrated cache, you're not getting it in integrated one. Now what I'm going to do is instead of point reads, I'm going to query without caching. So this query is like, maybe it might be cross partition query, like select star where blah, 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 which is not a partition key. And each time you query the database, be it the same query you are using for similar data results, you are, the cost of RU is 46. You're getting this much RUs for every request for that query. Now, what if you set this particular query and its result set in the cache? So this is what I'm doing. I'm using caching. So for the first time, whatever I'm querying, it will take some time because it goes to the database. It will store the result in the cache, and the rest of the if you see RUs are used are completely 0 RUs. So here you can see the difference how you can save on your RUs by using integrated cache. In the previous example, you used around 46 into 100 times of RUs, and here you just used 46 into 1 times of RUs and rest of the RUs were 0. So here you can have the flexibility of selecting your staleness, what time interval your cache should, purge and populate the data. It can be 1 minute, it can be 5 minutes, it can be more. So you have that flexibility based on how much staleness your application requires. Similarly, like, I have another example which I can show you is item cache. So here what it asks is, do you want to write a new item? Yes, I want to write. Suppose I'm writing a new item and submit X. I'm giving it a value as value. That's all. Do you want to write a new item? No, I don't want to write. Do you want to perform a point read? Yes. Do you want to perform with caching or without? Let me select without caching. Let me give what I've already added. Submit X. What it is giving me is 1 RU charge. Now, do I want to do a point read? Yes. Do I want to use caching for it? Yes. I'll give the same item. It is already cached. It is costing me 0 RUs, which was costing me 1 RUs before. So this is how my application with caching works, and this is how I'll just end my demo. So that was a demo on integrated cache, and I hope you liked it because that gives you a very it's a very powerful feature when it comes to your read intensive workloads. And with this huge volume of data and having concurrent reads, be it point read or be it querying your application or your database to be very highly responsive. On the other side, you also want to trade off with respect to the cost, where you don't where you want to optimize your cost. Integrated cache gives you that kind of uh, powerful feature to optimize it. And this is where you can, if you're not using it in your application or in your Cosmos DB, I would recommend to please go ahead and use it. Yeah. And with this, I'll start with another, topic of conversation, which is uh, worth talking about, which I like the most, the HTAP feature for Cosmos DB. So Cosmos DB or maybe any other NoSQL DB, when you think of, you will always think about highly responsive. I don't want any RTO, RPO. I don't want to, I want the high availability everywhere, and it should be highly responsive. What if you can do analytics along with it without doing any ETL and storing the data in a different store? What if you can store your transactional data in analytical form in Cosmos itself and perform some analytics on top of it? Uh, how does it feel? I am really happy with, when I get to know that this is a feature which we are bringing in. So Synapse Link is the feature with Cosmos DB. Synapse is an analytical tool where you do perform a lot of analytics, be it using Spark or using YAML or using your SQL while you're doing complex aggregations and all that. And Synapse now can do those powerful and complex computations where you can do some analytics and with respect to your business requirements, or maybe provide some contextual data to your customers, or maybe good insights using Synapse with Cosmos DB. So it minimizes your performance. This HTAP doesn't interrupt with your performance which is needed for your transactional store or OLTP store. It is completely isolated from your transactional requirements, and how I'll showcase. Now consider a scenario when there was no Synapse link. What are the ways you do analytics when you have your data in Cosmos DB? One, you do your analytics on your Cosmos DB data itself, on your OLTP data, where your data is stored in the form of JSON documents in row store format. What happens when you do that? You perform your group by, order by, or you perform your complex aggregations on top of it. You utilize a lot of RUs. You interrupt your, a low latency requirement for your OLTP workload. So this causes cost as well as a lot of latency. On the other side, if you want to avoid it and you want to keep it decoupled, what you'll do is your data is there in transactional store, move it somewhere in the data lake store, do your analytics using maybe Synapse Spark, or you use Databricks, or you use Synapse Analytics, or use any compute engine, etc. XYZ. Do your analytics on top of it, put it in Power BI, send it back to Cosmos DB or any push notifications. You have to think about managing a lot of complex ETLs, the formats of the data, and how you can trigger when you have to do the trigger of the pipeline and all that. What if you do you do your second part without of using your compute, without storing your data in a data lake store, and Cosmos provides you out of the box that kind of data lake store. So that's what we have come with, having a data lake store in Cosmos itself. So this is how it looks like. Consider you are not able to see your analytical store, but you have a Cosmos DB database or an account which is like a black box, which has two tables, or sorry, two containers. One container which is for which you have configured RUs, which is completely used for your operational data, where you require highly responsive database to, and with all the SLAs. Plus, you also have an analytical store where you store your data in the column store format, and this analytical store is in sync, where you don't have to do any management of the data. Your data is stored, and now you do analytics on top of it using some compute which you link with the store, how you link the compute with any other storages. What are the key benefits of doing that? One, the biggest benefit is skipping ETL completely, management of ETL completely. What is the other benefit? You are automatically syncing the data in your column store format, which is nothing but your tabular format, without which is getting inferenced automatically without setting the schema. It will create the schema automatically, inferring what is the type of the data. Third, what is the third benefit you get is on your RUs. You're not charged for your RUs. Even you're not charged as much as you're charged when you are storing your data in transactional store. So your analytical store, where the data is being stored, compresses it in a way that you are charged hardly a percent of what you are charged for your transactional store. And you're not charged for the usage of that analytical store. The RUs are completely isolated from what you are storing in your analytical store. And the last, what I can say, is the time to live. You have your data which is there in your transactional store. You want to keep it for 3 days, for 30 days, for 3 months. You put your time to live. The data will still be there in your analytical store, and you can decouple it and set a separate time to live for that data. It can be a year, 2 years, 3 years, however you want. So this is the pricing, which I can tell you that it gives you 63% cost reduction when you use Synapse Link, because your analytical store is less. You're not charged for the RUs. What you're charged for is the compute which you use on top of it, which is nothing but the SQL serverless or your Spark pool, which is comparatively less expensive than how you use a real-time RU, because this is an analytical workload, OLAP workload, and not the transactional workload. So I'll go to the demo, but before going to the demo, what I would like to show you is the problem statement for the demo. Consider that there's a mobile billing company where you want to use a very highly responsive database, which is responsive there to for their incoming outgoing calls, and setting up all the information related to incoming and outgoing calls. Along with that, what you want to do is you want to use that data uh, in your system to find to do some analytics for maybe service improvements, or giving offers to your customers or subscribers. You're using the data, you're using the call log application. You also want to do, like you want to create a baby container which has subscriber wise information about who the subscriber, what are the calls he has made, the incoming, outgoing, and what are the charges of the call. So these are the three use cases where the call log application wants Cosmos DB. One, to be highly responsive to track all the calls, incoming, outgoing, be it from any subscriber at any given point of time. to get the details with respect to the subscriber, and third is like, uh, to check or to have some visualization to find some scope of improvement. So that's where we use Cosmos DB for its transactional workload, also for logging all the calls and information, and also for the analytical workload, where it will be providing some visual reports to the Power BI dashboards to take some decisions on the quality, on the offers, or maybe improvements, and also using Cosmos DB to generate that bill document, which will, or bill container, which will have information related to every subscriber every month. So, this is how my one of my container looks like, where I have call records and where I have information about each and every call made from any of the subscriber. And this is again my another, container, which will look like, which will be like, which will give you information with respect to a subscriber, what kind of calls he has made and what is the total bill for that particular month. Now, let me walk you through a demo now, and the demo will completely showcase you what I have already shared on the billing app, and how they perform analytics using Synapse Link. So, here is the demo where what I'll be doing is I'm just trying to generate fake data. Before that, let me just take you to the Data Explorer, how I have created my. So I have these two container. One is called records and bills, as I had showed you. And right now I see that there is some few records in this already. What I'm going to do is I just try and add more records in it, where it shows me there are 15 rows. So when it comes to how it is coming in my SQL Server Management Studio in the first place, this is something which is OLAP, or maybe like a database which has structured data with columns. But I had my document database, right? So this is how I am doing. I have created my container with an analytical store. So before going to the other screen, what I'll show you is when I created my container, I gave my container name, like maybe, and I gave my partition key, what I wanted to give, and I selected analytical store. I want to enable it. And that's how this container has analytical store already enabled. Now, to do some analytics on the database, you should do it from somewhere where you have compute. For that, we are using Synapse Link. So I've created a Synapse workspace, and this is where I go, like to the Synapse Studio, which I've already opened it. So now in this, what I'll do is I already have a link created. So how do you create this link otherwise is you go to your link tab, a data tab, and link tab, and then connect to external data, where you select which particular API you want to select. I select Cosmos DB SQL API, and then continue. So this is how I'll connect with my Cosmos DB. I have connected with my account, and inside that there is like two tables or two records, containers, which is nothing but call records and bills. Now, what I want to do is I'll just see that the 100 data which I had populated later, am I able to see it over here or not? It takes 2 minutes. So now you are able to see, before you were able to see only 15 records. Now you are able to see more than that, 115 records. So all the records are there now in the analytical store. Now what I'll do is I am going to my develop tab, and I'm going to set the credential. This credential is nothing but like, it's a secret key to link to your Cosmos DB where your data is residing, so that you can do some compute on top of it. I just created, I'm using my master database here. Now, what I'll do is in this, I am going to create a view on my database. So I'm just going to go ahead and create a view. So if it is not created, it will create. If it is already created, it will show it already exists. So what I'm going to see is when I create the view, it will come here in the workspace where I can see what are my views, and I'm able to see there's a view created. Now with this view, what I'm going to do is once I created a database, I go to that to create a view. We have to first create a database. I'll go to that view, just do this and create. Once it is created, I am going to use this view in my Power BI. So I'll just open my Power BI. Here I've already generated. How you can add this is this particular source is go to the your SQL server and give your on demand SQL server, ID, what is the server name, what is the database name, and then import it. Okay. And that's when you do this, and you select which view you want to, you get this kind of, dashboard. On top of it, what I've done is I've created few visualizations like what is the type of call, is it international, it is local or national. So it gives me this view. So this is how the mobile billing company will use Cosmos DB analytical store, where it will be able to view and do get some insights on what are the improvements they can do and which are the customers which are using on regular basis their call log app, and how they can send some offers to the customer. The other is generating that bill container. For that, what I'll do is I'm using SQL on demand. Now I'll be using Spark to do that. So for this, I have created a Spark notebook. How you can do is obviously where your Spark code will run. It has to run on a particular a Spark, uh, what to say, queue or maybe compute. So here I have created a Spark compute already. What you can do is you can create a new Spark compute where you can select how many cores and what is the node you want to give. Once you do that, it will take some time to come up, and then you can use your notebook on that Spark node, the Spark SKU which you have created. I have selected that, and what I'm doing is now I'm loading whatever data is there in my OLTP. So this is my Cosmos link and this is my call records. And I'm loading from my OLAP. So my data which was there in OLTP, it got synced in OLAP, which I can see over here. And that's what I'm using. And I'm just, running and creating a data frame out of it. So in the previous one with SQL, what we did is we solved one of the problem of mobile billing app where they wanted to have some visualizations in terms of taking some decisions in terms of improvements. Now, this one is going to generate the bill. So, here, if you see, my bill doesn't have a bill container, doesn't have any data right now. And what I'll do is I'll write I'm written a Spark notebook where I'm loading the data from the OLAP to my local data frame. It is nothing but it has run, and now I'm just trying to print that print the schema. I'm going to unpack the data frame because the way the data has been added is in the form of like the entire ID which has all the key value pairs. If you can see that it's in the form of in this JSON. Every data is in the form of JSON. So I want to remove that and make it available in the form of string or integer, however it takes. And I also want to typecast whatever the date time is into form of date time instead of having it in the form of string. So this is what I do, and this is what I get the results. And these results, if you see, it's different from the results which we got over here, which is nothing but JSON. which is now removed, and we get the results how we want or we expect it to be. Now I'll be doing is nothing but converting this flat data frame into a nested one, because with each subscriber, what I want is I want the data which is all the information about incoming and outgoing calls based on that subscriber. So this is what I'm doing, and I'm attaching it as a separate column. So it will give me a start date, start time, and I'm doing all this on just one. I'm filtering it by only 1 month, so I should get only 1 month data in my database. So this is, and then what I'm doing is, apart from getting info about all the subscribers, incoming outgoing call, I also want to calculate the cost per month. So this is how I'm calculating the cost, and I'm attaching it over here, that every subscriber, this much is the total monthly cost of the subscriber for incoming and outgoing call. Now, last but not the least, what I'm going to do is going to insert this data. And where I want to insert is, I'm going to insert it in the OLTP, in the row store, where my transactional data is, so that that data can be used by my application. So here, point I can call out is, it's not OLAP, it's OLTP where I'm storing the data. So I'll just run this. It will take some time. Succeeded. So when I go here, I refresh, I get the data. So that data is nothing but, like, subscriber ID, whichever the ID is, in the month of June, he has made so many incoming outgoing calls, and this is the cost. Similarly, he is the subscriber ID. It's a different ID in the month of June, how many incoming outgoing he has done, and this is the particular cost. So this is how you can make use of Cosmos DB for your analytical workload, where I didn't have to do any ETL, and still I was able to see the data in my store. And I can also use using SQL, or I can use it using Spark, which I demonstrated now. So with this, I'll end the demo for HTAP as well in the Cosmos DB. So this was the end of our demo too. With this, I would like to summarize that, the powerful capabilities of Cosmos and the features which we discussed. One was integrated cache, which you can use, and extensively use when you have extensive read workloads, and you can save a lot of your cost. So if you're not using it, please go ahead, start using it. And the second bit is analytics on Azure, which will help you completely skip the ETL. And I'm sure any organization needs analytics along with real time requirement. So having analytics with Cosmos gives you a lot of benefits, where you don't have to tackle management of the pipelines, and still you can do your insightful analytics on top of it. Thank you so much, everyone.